And we are gonna now use our calculators to do the exact same thing that we were doing up until this point. Okay. If you have highlighters, get them ready. I need to watch out because I have a yellow background, so I can't use my yellow highlighter. Have your calculators ready to go as well. So normal CDF, this is very important, right? We're going to actually use this way more than a graph. A graph is limited, it's very time consuming. So we're going to use one of these functions to help us out. We use these when values do not appear on the graph. Okay, very important. To access that, we will press second vars, right? And then there will be either normal CDF or inverse norm. This is on page 18. Okay. What does normal CDF? I would strongly encourage you to add this to your study sheet. What does it need? It needs a lower limit, an upper limit, the average, and the standard deviation, right? And what will it do? It will calculate, right? It calculates the probability of data points existing between the two values. Okay. The answer is given as a decimal. We need to multiply by 100 to get the percentage. We will do that in a bit. Normal CDF needs 4 entries separated by commas. Lower limit is the value that would be to the left side of the curve. Upper limit would be to the right side of the curve. Okay. Remember, this is very important. Remember that if you get z-scores, you assume that the average is 0 and the standard deviation is 1. Please remember that. I don't need to tell you that. I do not need to tell you that. If there's a z-score, you just assume that that is true. Okay. Which is kind of why we often will work with z-scores, because I don't need to tell you the standard deviation and the mean. Okay. So normal CDF gives you the percentage between the values in a curve. Okay. Inverse norm does the opposite. Watch what inverse norm does. It needs the percentage of data, right, below, and I will make a little bracket here. You need to state as decimal. Okay. So percentage of data below the point. Okay. So imagine, just follow. I'm just gonna do this on the side, right? Maybe I have some room here. So if you envision, I will quite often just do this to illustrate a point. So let's say you're interested in this value along the x curve, right? You always want to give this value, like the percentage to the left of the value you're interested in. So let's say 40% of students scored below a certain score you're interested in, right? So this would be 40% would be below. Therefore, what percentage would be above the curve? You guessed it, 60, because we know the entire percentage is 100. But we're always interested in this one, always. So if this is the value we're trying to find, we want to enter the percentage that falls below it, right? So I will kind of make an arrow. This would be below. This would be above. Okay. So very, very important. to be stated as a decimal. So we'll calculate the actual value, right? It calculates the actual value along the x-axis we're looking for. So it could be height, it could be weight, number of days, it could be milliliters, you name it. And here's an illustration. If 35% of people earn more than 50 grand per year, then, right, if this is true, then we will go, hey, that means that it's 100% minus 35. That means that 65% earn less. Okay, and this is the one we're interested in. We're always interested in what is to the left. Okay, and so then inverse norm will tell you that. Okay, if 42% of students spend less than 15 minutes on homework, then not this group, a different group. 42% of students, if it gives you the percentage less than, right, that is below. That is automatically below. You kind of want to have a sense that the middle of the curve would be 50. This would be 50, 50. So 42 would be about right there, right? That is saying that 42% would be spending less, and this would obviously be our value that we are interested in, which is 15 minutes. In this case, I gave you that, but in the future, we will not know that. Okay, we'll try to figure that out. So I know this is cheesy, but think of Beyonce's song "To the Left," right? That if it helps you remember. That's all I got. I'm not really don't have anything else, but just remember everything you want the value to the left, okay? And I need you to graph this one more time. So the potato chips, I want to have the graph so we can use it to verify our answers. Okay, we need to see how that matches. So potato chips come in bags with a mean of 250, right? That's important. Mean weight of 250 and a standard deviation of 5 grams. The weights of the bags follow a normal distribution. That tells us a lot. We know what the graph looks like. Sketch a normal curve indicating the percentages plus or minus 3 standard deviations, label, and the z-scores and everything. Can you go ahead and do that? I will kind of get you started, but I won't talk a whole lot for this, okay? Don't forget your labeling. It's not the greatest curve I've ever graphed, but it's good. It's good enough. It will do. I will put z-scores. Just don't spend too much time on it because I'm gonna get going. And then be creative sometimes. Like if I ever asked you the percentage of bags that weigh less than 260, right? You could say, I'll just take 100 and just take away 2.5 from 100, right? And then you're left with everything else. You don't need to add up all these sections to get there, right? So sometimes it's beneficial to not, right, kind of do the indirect way, right? Subtract how many, the percentage of bags that weigh between 235 and 265. Maybe you want to take 100 and subtract 0.3, right, or 0.15 twice. But we also know it's 99.7 anyways from within 3 standard deviations, right? So sometimes you'll just know this is 95, this is 68, right, and so forth. All right, so let's use technology here. Graph is done. We're going to refer back to it. So very important. If I ask you to use your calculator, right, you will know there's 2 ways you will know. I tell you use technology, and the other one is you will not see the values along the x-axis, right? So you're like, wait a minute, like I don't see these anywhere. So you're stuck with having to use technology. So let's see here. Calculate the probability, right? That right there is a giveaway that you're going to have to use Normalcdf. The probability or percentage of bags that weigh between these 2 values, right? So this is telling us use Normalcdf, okay? So all I need you to show me is the entries. So you go Normalcdf. You don't need to tell me what you're pressing to get there. You're just going to go Normalcdf. And then you're going to say, okay, you want the percentage of bags weighing between this and this. So this is 232. This is 273. And we know that our mean is, I just gave it to you, is 250. And our standard deviation is 5. We will take this and multiply it by 100. We will multiply our answer by 100 because you're going to get a decimal. We want it as a percent. Just in your notes, okay, this would be the lower limit. This would be the upper limit. Soon, there will be instances where you do not have an upper or a lower. It's just saying more than this. That's all it's going to say. And I'll show you how we deal with that. So grab your calculators. I tell you what to press on the previous page. You go second, and then you press vars, variables, right? Second, variables. You should see this. And in this course, the only 2 I use is Normalcdf and inverse norm. Don't use PDF, okay? CDF, inverse norm. So you select CDF here, and we go and type in 232, 273, 250, and 5. Okay, so Sometimes you get percentages, like you're dealing with percentages. As long as you keep them all as a percent without converting them, then you're fine. Okay. Hit enter. We get 0.9998, right? So we're going to multiply that by 100. Not that we need to do it, right? But that's 99.98% of bags. Almost all of them. And let's verify this using our graph real quick. Remember 232 and 273? 232 would place you somewhere here, and 273 would place you, this would be 270 here, so 273 would be somewhere out here. So it makes sense that it's almost all bags are going to be within those two parameters. So how did we know it was normal CDF we had to use? Because that's the only one that gives you the percentage under the curve between values or above a certain value or below a certain value. That's the only one that does it. Inverse norm doesn't do that. Calculate the percentage of bags heavier, right? Percentage heavier than this. So it's basically saying 257 grams or more. Okay? So we're going to go normal CDF. Would you consider this a lower or an upper limit? What would you say? It's 257 or more. This is actually a lower limit. So we go 257 or more. So Dirksen, what do we do there? What do we do with the or more? Just pick a big number. So like ridiculously big, right? So if you're in the hundreds, I'm going to put in 100,000. Yeah, just pick a big number. If it's big enough, it's going to do the trick for us. It goes to infinity, right? Technically, the curve. And then you just type in your mean and your standard deviation. You multiply that answer by 100. Grab your calculator. I'm just going to go and copy my previous so I don't have to go find it again. So I'm just going to go 257, comma, 100,000. Mr. Dirksen, can I do a million? Sure. What about 999,000? Sure. So I like to write this down. So that's 0.0808. I multiply that by 100. So that's 8.08 if you round that to of bags. Not a whole lot of bags are expected to weigh more than that. Let's verify that. 257, remember that? 257? 257 is right about there. So just consider this. This is 2.5. And then we take some of this curve of this section, right? Because 257 would be right about there. And that's supposed to be 8%. And it would make sense, right? It would make sense because this curve goes down, right? So it's probably going to be about 8% there. Which means that if you subtract this from 100, right? 92% of bags or so would be weighing less, right? This is more. So let's do this. Calculate the percentage of bags weighing less than 243, normal CDF. Weighing less, so you got to be careful here. I'm going to go negative 100,000 because this is basically your upper limit. This is your upper in this case, right? We don't have a fixed lower limit, so we're just going to go extreme to the as far left as we can possibly get to cover all our bases, right? why am I saying this? Like, why can't I just give you a magic number? Because some questions actually have 100,000 as part of the number. There's a tire question. Tires last 120,000 kilometers on average. Then you would want to use millions here for your upper or lower limit. So just go ridiculous, right? Like just add a bunch of zeros and you'll be fine. So let's figure this out. How about, let's imagine you forgot how to do this, right? So you go second vars Normalcdf. There you go. Negative 100,000, 243, 250, 5, right? And that is 0.0. Where am I? I'm lost on my notes here. 243. Oh, I forgot the 0.5, right? Let's fix that. Comma 250, comma 5. There you go. There we go. That's better. 0, 0, 9, 6, 8. You multiply that by 100. Not that you need to, right? Some of you will just shift that decimal, but there we go. Okay, let's keep going here. I wanna skip some of this to get to inverse norm. I'm going to go to inverse norm. So come with me to page 20. G. The company would like to know the weight. It wants to know the weight, right? That would place 65% of the bags produced below. I'm going to use a different highlighter for below there. Below this weight. The company would like to know the weight that would place 65% of bags below this weight. If you're given the percentage, you need to use inverse norm. Okay. Percentage is given. Use inverse norm. Inverse normal distribution, right? So let's do a little graph here. Just a little sketch. Okay. 65% are below this weight. This is what we want, guys. So remember, this is 50. So if you want 65% below this weight, we're kind of assuming that it's right about there. This is the value we're after, where 65% are below, 35% therefore are above. But we want this. That's what we want. Okay. So we go inverse norm. We take this and we plug it in there, but as we do this, we divide it by 100, so 0.65, and then it needs the mean and the standard deviation as well. So let's go ahead and figure this out. So second vars, inverse norm, 0.65, 250, and 5. And that weight is, in this case, you need to base your units are based on what the question is giving you. Is it milliliters? Is it days? In this case, it's grams, right? Ooh, the bell is going to go. This is your homework to finish both of these pages, 19 and 20. And if you feel like you need more, the bottom of this has some textbook questions at the bottom. So page 19 and 20 for sure, okay? Homework, page 19 and 20. Thank you guys, have a great weekend. Please just do a little bit to practice this. We have 4 days next